Hello everyone, and welcome to the video on law of sines, law of cosines. I know this is coming to you either after the break or before the break, whichever one you happen to be most have the most time with. But I hope, regardless of when you're watching this, that you do have or had a wonderful time off and are just ready and raring to go come Monday or Tuesday when we're in class again. So this video, the skill objectives for this video are: number one, we want to solve angle side, AAS, or angle side angle triangle cases. We want to solve the ambiguous side angle triangle cases. We want to be able to solve side angle side triangle cases and solve the side triangle cases as well. And the fifth thing we're going to do is find areas of triangles using alternate area formulas. There's two different area formulas that we're going to be using. The difference between those area formulas and the one you're familiar with, the 1/2 base times height, is that in these two alternate forms, we're going to use side lengths. And in one form, we'll use an angle measure that's known from the triangle. So everything in the alternate forms is going to be directly from the triangle we're trying to find the area for. Now, we do have 4 different cases that we're going to look at. The first 2 cases are where we use the law of sines. In case 1, we're going to be told the measure of one side and 2 of the angles, the measure of 2 of the angles. So in the angle side, we get the measure of this angle, the measure of this angle, and then this side that is not between the two. Or angle side angle, we have the 2 angles and the side between it. So if we have those 2 situations right there, we will use law of sines to go and find solve the triangle, find the missing pieces, missing information. In case 2, this is where we have what's called the side angle, or what's also called the ambiguous case. And the reason it's called the ambiguous case is because in this situation here, where we're given 2 sides and then an angle that's not between the 2 sides, an angle that is opposite one of the angles, like beta is opposite side B. When we have that situation, you do have 3 different things that could occur. Number 1, you could have a no solution situation. Number 2, you could have a single solution, only one solution that satisfies all that information. The other one is that there could be 2 solutions. You could actually have 2 triangles that will satisfy the given information, but be very different triangles, look very different. So we have to be aware when we're dealing with this particular situation here that we could have multiple solutions, or we might have no solution. We just don't know. Until we start getting into the problem, we really can't say for sure which one it's going to be. Now we get to the law of cosine cases, the two cases, 2 types of problems where we will use the law of cosines. In the first one, case 3, according to the book, it's where we're going to have the measure of 2 sides and the angle between them. So we're going to know 2 sides of the triangle and the measure of the angle between those 2 sides. So that would be the side angle side case. And then the fourth one is where we have the measure of all 3 sides. Okay. Now when you have these, this is where you do use the law of cosines. Now, once you have that, once you do the law of cosines one time, then you really have an option. You can continue working with the law of cosines, or you could jump to the law of sines because you'll have enough information to actually do either one. So when we look at these triangles, what we're looking at is triangles that are other than right triangles. These are what they call oblique triangles, in that they're not going to have a right angle, but it could have an obtuse, or it could be 3 acute angles. Okay, and what we have in this situation is we have this triangle here. The side lengths are the lowercase letters, and then A, B, and C, and then the angle measures. There's alpha, beta, and that's gamma. What happens on there is that when we use the law of sines or law of cosines, law of sines is one that's pretty easy to remember. Law of cosines, as you can see, I've written down 3 versions of it there. But really there is a pattern that exists that can help you. So if you really only know one, you can apply it to each one. So law of sines. The law of sines is really a listing of three ratios that are equal to each other. And that is that the sine of alpha over A will equal the sine of beta over B, and that will be equal to the sine of gamma over C. Now, the next one is not in the book, but I do use this at times, just based on what I'm trying to identify. I think it makes your life a little bit easier. That you can also go through and say that A over the sine of alpha equals B over the sine of beta, which equals C over the sine of gamma. I will use this version up here when I'm trying to find an angle measure, and I'll use this version here when I'm trying to find a side length, because these put the side lengths in the numerator, this puts the angle portion in the numerator. One thing that you must remember though, in order to go through and use law of sines, you do need to have this information right there. You must be able to fill in one of these three pieces here. In other words, you have to know either, some of the given information would have to be alpha and A, or beta and B, or gamma and C. Okay, you need to be able to complete one of these fractions in order to use law of sines. Okay, law of cosines. When we look at law of cosines, you'll see it looks kind of like the Pythagorean theorem in some way. If you drop off this part that's subtracting, it really looks a lot like it. You get a squared equals b squared plus c squared minus 2bc times the cosine of alpha. Now I want you to notice, alpha and a are opposite of each other. B and C are the sides that make up alpha. When I look at the second one, b squared equals a squared plus c squared minus 2ac cosine of beta. And again, notice beta and b are opposites of each other, and sides A and C are the sides that make up angle beta. And when I get to the third one, c squared equals a squared plus b squared minus 2ab times the cosine of gamma. And again, the same thing is true here. Gamma is opposite of C. Okay, and A and B are the sides that make up gamma. So I'm hoping that you recognize the relationship that's there. If you recognize that relationship, then it really isn't a matter of knowing all three of these versions. If you recognize the relationship, you just need to know one of them, and you can apply that to any situation at that point. Finally, as you progress on these, some things that I want you to note here. Number one, the angles and sides share the same progression. In other words, what that means is that the largest side of a triangle is across from the angle with the largest measure. And the same goes for the smallest. The smallest side is going to be across from the angle with the smallest measure. So if you have that, if you keep that in mind, some of the stuff will work out and be helpful for you and make your life a little bit easier. Number two, make sure you draw the triangle and label the angles and sides. Okay, make sure you draw it out and identify the different pieces so that it's clear to you what piece you're trying to find and what information you actually know and how it relates to the information you're trying to find. Number three, if two angle measures are known, the very first thing you need to do is find that third angle. We can find that third angle by using the fact that the angles of a triangle add up to 180 degrees. So if I know two of the angles, I take 180 minus those two measures, I will get the measure of the third angle. And the next one is important. I've talked about this when we were solving triangles, the right triangles that we did in 4.3 and 4.4. Whenever possible, in successive steps, always return to the given values rather than using calculated values. In other words, whenever you possibly can, use the given information. Use that information because that's the only information you know is completely accurate. That is anything that's given to you, you can assume to be 100% true. And there's no variation, nothing at all there. Okay, the minute you use a calculated value, you are opening yourself up to if you made a mistake in terms of how you put the things together, or you're opening yourself up to rounding error because a lot of times the answers are not going to be nice numbers. There's going to be decimals and you're going to have to round things off. And the minute you round off and then use that value, you're going to compound the error. So whenever you possibly can, always use given information before you use the stuff that you've calculated. Now, it might not always be possible to do that. Some of the information you have, it might require that you're going to have to use the calculated value. But if you don't have to, that would be best. Now let's look at the first case. In this case, we have the angle side or angle side angle. So either one of these. And what I've given here, what we have in this information is we actually have the angle side angle case. So we have this angle right here is 102 degrees. We know this is 49, and I know this side here is 28. And what I need to do is I need to find A, side C, and the measure of beta. So remember the very first thing they said is, well, if you know two angle measures, the very first thing you want to do is find the third angle. So to do that, I just took the 180 minus 102 minus 49, and I found that the third angle happened to be 29 degrees. So I know measure of angle beta is 29 degrees. So now what I want to do is I need to find side A or side C. And what I'm going to do is we'll start out with finding side A. And so what I'm going to do is the first thing I'm going to go through and do is set up the proportion I want to use to solve this. And I'm going to use that version that I told you that I'll use sometimes. It's not necessarily in the book. The one with A over the sine of alpha equals B over the sine of beta equals C over the sine of gamma. And I'm going to use those first two. I'm going to say that A, in this case, A over the sine of alpha equals B over the sine of beta. So from this information, what I can then say from this is I know that I'm trying to find A, so A over alpha in this case was 49 degrees. That's this angle right there. That's the side. That's the angle across from there. So that's going to be the sine of 49 degrees equals B, which is the 28, over the sine of 29 degrees. That piece of information that we found earlier. And so solving that thing, I just multiply both sides by the sine of 49. I find that A equals the sine of 49 degrees times 28 over the sine of 29 degrees. And all I have to do now is put that into the calculator, put that in there, and I come up, when I do that, I will come up with that being about equal to 43.59. In this case, the units are feet, so 43.59 feet. At this point, if you haven't already done so, I would like you to pause the video and put this right here, this calculation, into your calculator. Make sure you get that answer. Some of the things that could cause a problem if you don't get the 43.59. Number one, make sure you're in degree mode, or that you use the degree symbol on the angles. If you're not doing one of those, then this one is not going to work out, because it's going to be treating the angles as radians, and that's going to throw things off. The other thing is, make sure that you close off each trig function. On the TI 83s and 84s, when you press the sign button, there will be a parenthesis that will show up. So you do need to close that off. And that can cause more of a problem right here, because if you have the parenthesis but you don't close off this sign function, it's putting all of this inside that sign function. So do the one, if you're already in degree mode, or you use the degree symbol and you didn't get the right answer, more than likely it came from right there. So go ahead, pause the video, make sure that you get 43.59, and when you come back, we'll talk about what you need to do from that point forward. Okay, welcome back. If you are still having problems, make sure that you put a note here so that we can check this in class with your calculator. But I'm hoping that everybody did well with this. What I would like you to do right now is I want you again to pause the video, and I would like you to find the length of side C. So I want you to find this length. Now, in order to do that, we're going to use given information. I would use this angle with that side, so 29 and the 28 feet, and then the given angle 102 with C. So set up your ratio, your proportion that you need to solve, and then solve for C, and then once you get done, come back and we'll take a look and see how you did. Welcome back. I hope you were able to go through and get things set up. The way you should have ended up setting this one up would be C over the sine of 102 equals 28 over the sine of 29 degrees. And then by multiplying both sides by sine of 102 degrees, I get C is equal to the sine of 102 degrees times 28 over the sine of 29. That would be a 29 right there. And that, when you put that into your calculator, that does come up to be about 56.49 feet. So with this, what I've done now is I've solved this triangle. I found all the missing information. I found that angle beta was 29 degrees. I found that A was about equal to 43.59 feet. And I know that side C, actually side A, sorry, and side C is about equal to 56.49 feet. Now we'll get to the side-side angle, the ambiguous case. This is another one where we use law of sines. So on this particular problem, what we're given is that this angle here is 85 degrees. I'm told that this side here is 25 and this side is 15. And I want to find this angle, angle gamma, angle beta, and the length of side C. So in this situation, I only have one angle, so I can't just automatically jump to getting all the angles here. What I do have, though, is I know that 85 is across from 15. And so that's one of my fractions I have to use. And the only other information I know is that this side over here is 25, and that's across from beta. And so by law of sines, I can set it up. This time I'm going to use the version that is actually in the textbook, which is the sine of alpha over A equals sine of beta over B, which equals sine of gamma over C. And I'm just going to use the first two. I'm going to use the fact that the sine of beta over 25, because beta is across from 25, is equal to the sine of 85 over 15. 85 is across from the 15. So to solve for sine of beta, I go through and I multiply both sides by 25. I get sine of beta equals 25 times the sine of 85 degrees over 15. Now I put that into my calculator and I get sine of beta equals 1.6603. Now right away, thinking back to what we talked about in the previous sections there, we know sine always takes a value from -1 to 1. Well, this value here is too big. That value is greater than 1. And that's so that the sine of beta cannot be 1.6603. So in this situation, this is one of the cases where we're looking at that case 2, the ambiguous case, where we have no solution. You will know that. You'll know you have no solution when you try to find the first angle and you get a sine or cosine value, that would be impossible. Where you get this value that you have here would be something bigger than 1, well, actually it's just going to be bigger than 1 because you're not going to go into negatives on this one. So if you get something here that's bigger than 1, you know this is not possible and there's no solution to this triangle. Now let's take a look at another case with this. In this situation here, it's a side-side angle case. What I'm given, I have this triangle over here. I'm told this side is 12, that side is 31, and this angle is 20.5 degrees. And I want to find gamma, beta, and C. Well, like the last problem, the information is set up for us to find, the first thing we have to find is beta. So I go through on this one, and I get the sine of beta over 31 equals a sine of 20.5 degrees over 12. Solving for sine of beta multiplied by 31, I get sine of beta equals 31 times the sine of 20.5 degrees over 12, and that comes out to be 0.9047. And so what I do is I take this, I go and to find beta, I'm going to do the inverse sine from my calculator. So I'm going to go through and put second sine of 0.9047. So you go and do that right now. And what you should come up with, if you want to be in degree mode, you should come up with beta equal to 64.8 degrees. So now we know that we have at least one solution. What I need to do is to identify, do I have a possibility of a second solution? And really what it comes down to is this. If this angle that we found has a measure bigger than the angle we're given, then we do have a possibility of a second solution. If this angle here was smaller than the given angle, then we would only have one solution. So I know in this case that I do have a second solution. I do have a possibility of a second solution. And the way I find that second solution, I have the second answer for beta. I'll call it beta 2. And that is going to be that I take 180 degrees minus the value, the answer I got. So minus the 64.8 degrees. And that will give me my second possible value for beta, which in this case comes out to be equal to 115.2 degrees. So now in this case, with this situation here, I know I actually have two solutions, and I have to actually find the two values for all my answers. So in this case, I know I already have identified my two values for beta as 64.8 degrees or 115.2 degrees. But that also means that I have two values for gamma and two values for C that I'm also going to have to find. So to do this, the first thing I'm going to do is I'm just going to kind of break, oops, I forgot my pen. I'm going to break this up into the remaining region into two pieces. And in this first piece over here, we're going to use when beta is about equal to 64.8 degrees. And over here, we're going to use beta 2 when it's about equal to 115.2 degrees. So at this point now, I do have, yes, they're calculated values, but I do know the measures of two of my angles in this triangle. So what the first thing I'm going to do is find the measure of gamma. And what I can say in this first case is gamma is equal to 180 minus the 64.8 minus the 20.5. And when I put that all into my calculator, I come up with that equal to 94.7 degrees. So I know that in the first case here, where beta was equal to 64.8, that gamma would be 94.7 degrees. In the second case, so I have gamma 1, and now I'll have gamma 2, is equal to 180 minus the 115.2 degrees minus the 20.5 degrees. And in this case, when I do that, so that comes up to be that, that gamma 2 is equal to 44.3 degrees. So now the last thing I will need to do is find the length of C. Now, in this case, I can use the law of sines again, and I know that C over the sine of 94.7 degrees is going to be equal to, we'll go back to the two pieces that we know, the 12 and the 20.5. So 12 over the sine of 20.5 degrees. So putting that into your calculator, I get C is equal to, it will be the sine of 94.7 degrees times 12 over the sine of 20.5 degrees. And when I put that into the calculator, that is going to come up to be about 34.15. So the answer there, that's going to come out to be about 34.15 23.15. So what I'd like you to do is double check your calculations, double check my calculations, see if those are correct. And once you've done that, I would like you to come over here, and I'd like you to set up over to the second one. I'd like you to go and set up a proportion that we could then use to find our second value for C. Okay, welcome back. I hope that when you went through and you were able to go and duplicate this value over here. If you weren't, again, double check your parentheses and mode to make sure everything is in the proper location. In terms, I also asked you to go and set up the proportion that we can use to then solve for C in the second case, where beta was equal to 115.2 degrees. And what I come up with in this case is that C over the sine of 44.3 degrees equals 12 over the sine of 20.5 degrees. And then C will equal, multiplying both sides by the sine of 44.3 degrees, I get C equals sine of 44.3 times 12 over the sine of 20.5 degrees. And when I put that in the calculator, I get that C is equal to 23.93 units. So double check. Hopefully you were able to come up with that as well. We're in decent shape. Now again, remember, this was a two-case situation. If when we solved for beta, when we found beta 1 initially, again, I want to make sure this is clear. If beta 1 was an angle that was smaller than the given angle, then I would not have to worry about the second case. The second case would not be a possibility at all. I would just have to worry about this portion right here. But because this angle was bigger than what was given, I know I have two different solutions I'm going to have to find. And in this case, they happen to be these two here. Now we get to the case 3, which is the side angle side case. So on this one right here, what I'm given is I'm told that this side over here is 9, this side is 12, and the angle between them is 25 degrees. So this one right now, it's just set up for us to do this one. Since we don't have... we do have two side lengths, but we don't know the measures of the angles opposite those. And we have one angle, but we're still missing that side. I know I can't use law of sines on this one. I have to use law of cosines. And so what I'm going to do is I'm going to use law of cosines, and I'm going to use it to find A. So setting it up with law of cosines, I know that A squared is going to equal 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of 25 degrees. Now, at this point, you go through, do the calculations with that. Now, the one thing I want you to make sure you do on this one is make sure you don't go through and take these two and then multiply these and combine them. These three here are also multiplying cosine of 25. So you've got to deal with this and then this whole thing separately in terms of calculations. The other option is just put it into your calculator. Put it in as 9 squared plus 12 squared minus 2 times 9 times 12 times the cosine of 25 degrees. You press enter on that, you will get the correct answer. And what you'll find is that A squared, A squared will be about equal to 29.2375. And then using the calculator, taking the square root, I find that A is about equal to 5.4072. Now at this point, I now have my 25-degree angle, and I do know the side opposite that angle. So what I can do is I can use the law of sines, and what I'm going to want to do is use the law of sines to find the smallest angle I have left to find, which in this case, because of the proportionality aspect of it, I know my smallest angle has to be beta because 9 is less than 12. So the next thing I can do is then I say, well, the sine of beta over 9 is going to be equal to the sine of 25 degrees over my answer for A, which was 5.4072. At this point, I go through, I solve it for the sine of beta. By multiplying both sides by 9, I'll get that the sine of beta is equal to, or is about equal to, 0.7034. And so therefore, I know beta equals the inverse sine of 0.7034. And putting that into the calculator, I come up with that being about 44.7. Now, some of you should be looking at this saying, wait a second, why is it that, with this we have 44.7, but we know with the law of sines we do have a possibility of two solutions. Why would we use it here? Well, here's the thing. Yes, we do have a possibility of two solutions, but our other possible solution on this one would be that beta 2 would be about equal to 135.3 degrees. But here's the thing that I know. Remember the whole thing. I know that beta has to be smaller than gamma because the side across from beta is smaller than the side across from gamma. Well, if beta, that's why we wanted to pick the smaller one, because if beta has to be the smaller angle, there's no way that beta could be 135 degrees. And so, therefore, this one here is not a possibility. My only possible value for beta is 44.7 degrees. Because if beta was equal to 135.3 degrees, that gamma would have to be an angle smaller than beta, and therefore the side across from gamma would have to be smaller than the side across from beta. And that's not the case in this problem. So I know beta has to be 44.7 degrees. And therefore, since beta is 44.7, to find gamma, I know that I'm just going to use the fact again that all the angles of a triangle add up to 180. And so I'm going to take gamma equals 180 degrees minus the 25 degrees minus the 44.7 degrees that we just found. And we find that gamma, the last angle that we have to locate there, comes out to be 110.3 degrees. And so I've solved that triangle by starting out with initially using the law of cosines right here. And once I had things set up, I used the law of sines. And a lot of people like doing that too, just because the law of sines people find to be a little bit easier to use than the law of cosines. With case 4, we have the side, side, side version. In other words, we know all three sides. We want to find all three angles. And so what I'm going to do on this is I'm going to go through, I'm going to use the law of cosines to start out with, and we'll then, once we, again, do the law of cosine once, then we'll be able to use the law of sines after that. So in this case, what I'm going to do is I want to use the law of cosines to find the biggest angle in the triangle. Now, I'll know that because I know the biggest angle is going to be across from the longest side. So in this case, I know that my largest angle has got to be gamma. And so, setting it up with the law of cosines, remember how the law of cosines works. It's going to be that 19 squared is going to equal 8 squared plus 14 squared minus 2 times 8 times 14 times the cosine of gamma. Now, I can go through at this point, I do some algebra, and I solve this. I solve it for the cosine of gamma, and I come up with the cosine of gamma equals 8 squared plus 14 squared minus 19 squared over 2 times 8 times 14. And when I put that into the calculator, I'm going to come up with the cosine of gamma equal negative 0.45089. So what I'm going to do then at this point is I'm going to use the inverse cosine, and I know that gamma will equal the inverse cosine of the negative 0.45089. And when I put that into the calculator, I find that gamma is equal to 116.80 degrees. Now, once I have that information, then I can go through, because now I know the angle gamma right there, and I know 19, so I know I have the information, enough information to set up law of sines. And it really doesn't matter which one I find at this point. I'm going to find alpha. Okay, I try to find the smaller one second, so I'll do that, with this one now. So I know, setting it up with the law of sines, I know the sine of alpha over 8 is going to equal the sine of 116.80 over 19. Now, multiplying both sides by 8, I get that the sine of alpha is 0.37583, which when I put that into my calculator using the inverse sine, I get that alpha is 22.08 degrees. And now, since we know that angle is smaller than what we started with, we don't have to worry about a second solution. So we have the 22.08, we have the 116.80, and then I can go through and find the measure of the third angle by taking the difference between those with the 180. So I know that angle beta is going to be 180 minus the 22.08 minus the 116.80 degrees. And so when I do those calculations, I find that beta comes out to be equal to 41.12 degrees. Now let's take a look at the area formulas. Now I've broken this up. There's a lot on this slide, but just kind of want to just go through these real quick and then call it good at this point. We can talk more about them in class too. But what we have are the two different versions of area formulas for a triangle. The first one, the book calls the side angle side version, because what we're going to know in that case is we're going to know two sides and the angle between them. And what we find with that is that the area of the triangle is going to be 1/2 times the product of the two known sides and the sine of times the sine of that angle between them. So you can see that here, the AC times the sine of beta, or AB times the sine of gamma. In this case, I look at this problem. I have that's 52, that's 90, the angle's 102. I want to find the area of that triangle. And so I take area equals 1/2 times 52 times the sine times 90 times the sine of 102 degrees. I just put in my calculator, and I'm going to get something that's pretty close to 2,289. So that would be the area of that triangle. So whatever the square units of what that is. The second version is what's called Heron's formula. Now, this formula, for whatever reason, it does make its way a lot on standardized tests. I've seen it on the Michigan stuff. I've seen it in terms of the ACT prep. I think a lot of it is because this is a formula that works that a lot of people are not necessarily completely familiar with, but you can use it, and it's just checking to see how well you take something you're not necessarily familiar with, but plug things in. Well, the way this one works is this. I'm taking the area of this. The area is going to equal the square root of S times S minus A times S minus B times S minus C. Now, A, B, and C are the lengths of the sides of the triangle. S is equal to A plus B plus C divided by 2. Make sure you're careful with that. A lot of people, they make a mistake with that because they start thinking the average. It's not the average. It's going to be always divided by 2. So make a big note of that right there. And so when we have this triangle, I have a triangle here. It's 43, 53, and 72. So S is going to be 43 plus 53 plus 72 divided by 2. And if you put that into your calculator, you're going to find that that's equal to 84. And so the area is equal to 84 times 84 minus 43 times 84 minus 53 times 84 minus 72. which that's just going to be the square root of 84 times 41 times 31 times 12. And when I put that into the calculator, it comes out to be about equal to 1,131.89. So that would be the area of that particular triangle. This does now conclude the video on for sections 4.4 and 4.5. I know it's a longer one because there's a lot of different situations we had to deal with, and it does cover 2 sections. So with that, we have finished that, and this again is due for the first class after the break. So either for Monday for the A-Day classes on January 5th, or on Tuesday for the B-Day classes, because at this point, at least for the remainder of the semester, A-Days are going to lead. So that will happen up until at least exam time, and I think after exams, B-Days will start leading again at that point. So anyway, I hope if you are doing this at the beginning of break, I hope that you do have a wonderful, wonderful time off. Enjoy the holidays. Happy New Year. And if you are doing this after the break, it's like the either Sunday night on the January 4th, or for the B-Day people, maybe even January 5th. I do hope your break was wonderful and that you had a great time with your family and friends, and that you did get a lot of rest. And we come back and we are approaching the end of the semester, and then after exams, it's just we're over halfway done, and we go through and we're getting closer and closer to summer. So we'll see you all in our next class. Take care.